Hey class, today we're going to be talking about the electromagnetic spectrum, Bohr model, and...
Alex, wait! Markers are dangerous. Wear safety goggles.
Ben, do you ever wonder how ancient chemists discovered compounds and what kind of molecules were in them?
You know, I do. It keeps me up at night.
Well, I heard that a lot of old chemists used flame tests.
What's a flame test?
Well, basically, you just burn the substance and see what color it gives off, because they knew by burning other substances that certain chemicals give off certain colors of light.
No way!
Let's check it out. Flame tests work with the electrons of the atom. When the atom is heated, an electron in a lower sublevel becomes excited and jumps to a higher sublevel. It stays there for a certain amount of time, but when it has no energy left to remain at that upper sublevel, it drops off back to where it once was. In that process, it gives off a photon, the basic unit of light.
This is an electron orbiting in the first sublevel. It gets hit with some energy and moves up into its excited state on the second sublevel. Eventually, it will lose its energy and fall back to the sublevel, emitting a photon.
This is the electromagnetic spectrum. It's a range of all the different types of waves in the universe. Today, we are only going to deal with this section right here, which is visible light. When an electron falls back from an excited state to a ground state, a photon is emitted. And that photon can fall anywhere on this electromagnetic spectrum. But what we see, and therefore what we focus on, is in this visible light spectrum. So now I understand why burning gives off light, but I don't understand the different types of colors that it gives off.
The color depends on where the electrons fall from. An electron falling from a higher position will give off a different color than an electron falling from just the second sublevel. All of the electrons in an atom become excited. Each of them will give off a certain wavelength, meaning a certain color, when they fall. The color of the compound depends on the combination of all the electrons that are falling. So, now we know what we're doing. What's the obvious next step?
Let's burn stuff! Alright, that's gonna be like a 9-minute clip.
Due to several safety and fire code violations, I had to put a stop to the original video that they were going to show on this.
Potassium burns purple. Look right at the bottom of the flame and you can see that. Strontium is a red-orange color. It stands out very clearly. Lithium is a very pretty red. Some would say fuchsia. Sodium looks like a regular flame, just a yellow-orange color. Copper is a blue-green. It gets more blue the hotter it is, but it's only green. Boron is also green.
So Ben, what did you learn today?
Well, I learned about flame tests and how early chemists used to use them to tell which element was in which compound. Also, I learned that the reason that we can see those colors is because an excited electron falls back to its ground state, it emits a photon.
Wow, that's great. And make sure you guys remember the 6 most important basic flame tests that you will probably see in the future. Potassium's purple, lithium's red, sodium's yellow. These ones are very important, as are boron
This
being green,
is an electron
copper being
orbiting
a
on
tealish
the
color,
first
and strontium being
sublevel.
orange.
It gets hit with
One
some
last
energy
thing.
and moves up
Remember,
into its
kids,
excited state.
Leo says...
Oh, Mr. Copeland!